Welcome to another exciting educational video brought to you by Upvision Concepts Academy. So today is chemistry and we're looking at energy changes in chemical reaction. And chemical reactions involve the breaking down of bonds in reactants and formation of new bonds in products. These processes are always accompanied by energy changes, which either absorbed or released in form of heat, light, or electricity. So we'll be looking at different things today. We'll look at exothermic reactions and endothermic reactions. So these two concepts, very, very important. Exo is outside, exothermic reactions. And we'll also look at endothermic reactions. So for exothermic reactions, they are actually reactions that involves the release of energy, outwards release of energy. So into the surroundings, the things that we look out for here is that the temperature of the surrounding increases. So when the reaction is occurring, for instance, reaction is occurring inside here. These are reactions. You see that at the end of the reaction, you have increase in temperature in the surrounding. You understand? Heat is given out. That's why you say exo, out. So heat is given out. Then the enthalpy change. Enthalpy change is negative. Okay, so if heat is given out, enthalpy change is equal to negative. This is it, negative. So enthalpy change is negative. We look at enthalpy, what it means later. Okay, so but on the other hand, exothermic reaction has to do with reactions that occur when heat is absorbed, from the surrounding. So in this case, maybe you have something heating here, the heating absorbed from the surrounding affects the reaction, and then you have the endothermic reaction. For endothermic reaction, the enthalpy change is positive. The enthalpy change is positive. So we'll look at this in details. Just stay tuned, sit tight, subscribe, wear your seat belt, and enjoy the class. Okay, so we're going to just dive into exothermic reactions. And as I said, these are reactions that release energy to the surroundings. So energy is released to the surroundings when the reaction is occurring. That means that the temperature of the surrounding will increase. So if you look at the containing vessel where the reaction is happening, the exterior part of the containing vessel will have some kind of warmth or increase in temperature. Another thing that we notice is that heat is given out. So that is the term exothermic. Heat is given out. And the enthalpy change is negative. These three things are what we should look out for when we are defining what exothermic reaction is. Examples of exothermic reaction includes combustion of fuel, when, of course, you know when methane is burnt in presence of oxygen, you have carbon dioxide and water, heat is released. So when you have combustion of fuels, you see exothermic reaction in place, heat is given out, the heat in the surrounding is increased, and the enthalpy change is negative. Also, another kind of reaction that is an example of exothermic reaction is neutralization reaction. This is where acid and base mix together to form salt and water. Heat energy is released. So this is the energy for exothermic reaction. And respiration, just giving out oxygen, taking in oxygen and giving out carbon dioxide. You see oxygen is taken in and carbon dioxide is released. Water is also part of what is released, and energy is released. So the features for this kind of reaction is that number one, that the energy content of reactant is always greater than that of the product. Hence, heat is given out. So energy content of the reactant is greater than that of the product. Second feature in exothermic reaction is that the graph, the reactants start high and the product will end low. So for exothermic reaction, it looks like this. So this is reactants and this is products. So it starts high and ends low, showing that heat is given out of so we'll look at the endothermic reactions, endothermic reactions. So these are reactions that absorb heat from the surrounding. So you have the surrounding, it takes in heat so that it can work. Okay, so what are the features of this kind of reaction? The temperature of the surroundings drop. So when that reaction is going on, the temperature of the surroundings drop. So heat is taken in, of course, and the enthalpy change is positive. It's positive. So look at these terms when you are defining endothermic and exothermic that we just discussed. For exothermic, the enthalpy change is positive. Remember, exo means out. The heat is going out. And if it is going out, it means that the exterior surroundings of the reaction is hot. Heat is taken from inside and taken outside. So the outside surrounding is hotter than the inside. So the enthalpy is negative and heat is taken out. But on the other hand, on the flip side, you have endothermic reactions where the heat is taken from the surrounding into the reaction, and the heat the temperature of the surrounding drops, and the enthalpy is positive. So what are the examples? Photosynthesis is the reverse of respiration. It's the reverse of respiration. So remember that respiration is exothermic and photosynthesis is endothermic. So where you have carbon dioxide and water reacting, oxygen is liberated, and it requires sunlight to happen. If you notice, the area where the plants are exhibiting photosynthesis, that area is cooler. That is why when you stay under the tree or under where vegetation is, you experience cooler atmosphere, because the reaction that has happened in this process of photosynthesis has made the exterior environment of the plant to be cooler. So that is the explanation in chemistry. So another example of endothermic reaction is thermal decomposition of calcium carbonate. Thermal decomposition, that is when you heat it. When you heat calcium carbonate, it decomposes and forms two products. The one of them is calcium dioxide and carbon dioxide. And the third example here of endothermic reaction is dissolving ammonium nitrate in water. So when you do that, you see that you have an endothermic reaction going on. Okay, so we have enthalpy change on the board. So enthalpy, H, is the heat content of a system. That is the heat that is present inside a system. So enthalpy change, delta H, is the difference in heat content between the product and reactant during a chemical reaction. So if I have this formula, this defines enthalpy change. It says enthalpy change is equals to enthalpy of the product minus the reactant to give me this change. Now, if this change is positive, it means that the reaction is endothermic, and if it is negative, it is exothermic. Let me explain this very well so that you understand the concept. Remember, we said that exothermic reactions are reactions that give out heat. It goes out. That means if I have a containing vessel where my product and reactants are in, they are reacting inside, the temperature outside here is higher than the temperature inside here. So the temperature here, H delta change in enthalpy here is negative. Is negative. Why is it negative? Because it is given out. The product is more than the reactant. The reactant is more than the product. So the reactant is here. The energy, the temperature rating inside here is higher than the one outside. All right. So if the product is higher than the reactant, or the reactant is higher than the product, then you have a negative enthalpy, and a negative enthalpy means that it's exothermic reaction. Now, if the product is higher than the reactant, that means the environment is having more heat than what's inside the environment, then you have an endothermic reaction, meaning that the enthalpy change is positive. So this is very consistent with what we have said before, that enthalpy change less than 0 means it's an exothermic reaction. Understand? Enthalpy change greater than 0 means it's an endothermic reaction. So note these terms when you are defining enthalpy change, and the unit of enthalpy is kilojoules per mole. So sometimes in a chemical equation, the equation is written and the enthalpy is given as either a positive or a negative kilojoule per mole. From there you will know that sign, positive or negative, will make you know whether the reaction is exothermic or endothermic. Now let me just do an example on the board. Sometimes in your exams you see something like this. You'll be given a reaction, or a chemical equation, and information inside that chemical equation will include the enthalpy change value. So for instance now, if I'm having this compound, methane, reacting with water, let's say water, no, oxygen. This is combustion that I told you about, combustion. So this is water liberated, and you'll be given enthalpy change as minus 890 kilojoule per mole. Now, if you see this information with this chemical equation, just use this minus sign to know that that reaction is exothermic. Why? Because the enthalpy change is negative. Now, if I have, we all know that this is a combustion reaction and enthalpy change is negative, and the reaction is exothermic. See what I'm using? The terms I'm using. The reaction, the name, the type of reaction, exo or positive, exo or endo. Exo is out. The energy heat energy is given out. You understand? And endo absorbs energy from outside. Energy from outside. So this is already exo because it's one of the examples for exothermic reaction, combustion, burning of methane. So, but this value here, without even knowing the kind of chemical reaction is, once you see this value outside, this 0, negative there, it shows that this is an exothermic reaction. Heat is released. Heat is released. Okay, so we look at activation energy. What is activation energy? Is defined as the minimum amount of energy required to initiate a chemical reaction. So you see, reactants and products will collide. Sorry, reactants must collide with sufficient energy. So activation energy is just that threshold where this reaction should exceed before reaction will occur, or what this collision should exceed before the reaction will occur. So if the activation energy is if the energy exceeds activation energy or is equal to activation energy, the bonds are broken and new ones are formed. Okay, so it's just like saying that it's a threshold. It's a threshold. So two compounds or two, I have reactant A and reactant B are on the verge of reacting. You're bringing them together. Once the reaction starts, once they start meeting, a point will be reached. There's an energy level that is required to be exceeded or to be equaled for reaction to occur. For the collision of these molecules can result to new ones, because chemical change is where totally new substances are formed. You understand? So that threshold of energy that must be reached or exceeded before reaction will occur is known as activation energy. So for activation energy, the higher the activation energy, the slower the reaction unless catalyst is used. Okay, so if for instance the activation energy is very high, it means that the reaction will take some time for it to occur. But if it is low, the reaction will just occur seamlessly. So, but the only way activation energy can be reduced for a reaction to occur very fast is when you introduce the use of a catalyst. So a catalyst, just what it does is that it lowers activation energy. So let me just write it here. Catalyst. Number one, what it does is that it lowers activation energy so that the reaction can actually happen. If not, you will just be there, all of us will just be there watching the reactants and products. Number two, it provides alternative pathway with lower energy requirements. So this is another feature. It provides an alternative pathway, with lower activation energy. That's what a catalyst will do. And finally, it speeds up both exothermic and endothermic reaction. So whatever kind of reaction that is going on, catalyst will speed up both endothermic and exothermic reactions. So these are what catalysts will do in conjunction with activation energy. Okay. Okay, so I have a NECO-style question on the board. The first one here says if enthalpy, change in enthalpy, is equals to plus 75 kilojoule per mole for a reaction, the reaction is A, endothermic, B, exothermic, C, catalytic, and D, neutral. Now from what we have discussed, the answer is A, endothermic. Why? Because the reaction has to do with the reaction that absorbs heat energy. So it absorbs heat energy, so that means the energy inside is hotter than the one that is outside. So the enthalpy change is positive. Why? Because the change in product minus reactant is positive. Remember the formula? Delta H is equals to P minus HR. That is, if the product is more than the reactant, enthalpy is positive. That is why the enthalpy here is positive. So the product is higher than the reactant. That is why we have that answer as A. Okay. So it's endothermic. The other way around is exothermic. All right. So the next question here says, which of the following is exothermic reaction? Remember, we listed the exothermic reaction and saying that this is actually endothermic because the heat outside is lower, outside is cooler, so it's endothermic. This one is exothermic because heat is given out. So the answer for this one is B. Okay. All right. So in summary, we're able to look at the various kinds of reactions, that is according to the heat that is given out, endothermic and exothermic reactions. We're told that exothermic reaction has to do with releasing of heat, so that delta H for exothermic reaction is less than 0, remember, and endothermic reaction is where heat is absorbed, so that delta H is greater than 0. We also looked at the enthalpy change, the difference between product and reactant, that is this, product and reactant. So if we have positive here, it means that a reaction is endothermic, and if you have negative, it means that it's exothermic. So look at catalyst, what it does. Catalyst lowers activation energy and speeds up reaction. Please note that. Catalyst lowers activation energy and speed up chemical reaction. And also we looked at activation energy as the minimum energy required to start a chemical reaction. If that activation energy is not achieved or exceeded, chemical reaction will not start. Please take note of this. More WAEC NECO questions will be on the description. If you're not subscribed to our channel, please subscribe to our channel. And I hope this video has been informative for you. I'd like to thank you for